Okay, get this. Imagine taking a major greenhouse gas, something like CO2, and with just a simple, perfectly timed zap of electricity, turning it into pure, high-energy fuel. I mean, no waste, no byproducts, just a perfect conversion. Now, that might sound like something out of science fiction, right? But it turns out the secret isn't some brand new wonder material, but a very specific rhythm. I mean, this is one of the biggest questions in energy science today. Could we actually take the CO2 that's already in the atmosphere, the stuff we're trying to get rid of, and convert it into something incredibly valuable, like ethanol, a clean liquid fuel? For decades, this has been the holy grail. The problem is, whenever we've tried to do this, the reality has just been, well, messy. The goal, the dream, is a clean stream of ethanol. But what we actually get is this chaotic soup of different gases and alcohols. We're talking methane, ethylene, carbon monoxide, just a whole hodgepodge that takes a ton of energy to separate and purify, which kind of defeats the purpose. So the real problem here boils down to one word: chaos. The best, most affordable material we have for this job is just simple everyday copper foil. But when you apply a constant electrical voltage to it, the CO2 molecules just break down in all sorts of unpredictable ways. The chemical bonds form randomly, and you have absolutely no control over the final product. But what if there was a way to just cut right through all that chaos? A technique so precise it's being called a kill shot, a perfectly timed solution that forces the exact outcome we want every single time. And this is where the whole approach just flips on its head. Instead of just blasting the system with more and more energy and just hoping for the best, researchers started asking a totally different question. What if the solution isn't about brute force at all? What if it's about a specific, carefully timed rhythm? And that led them to the first part of a very, very specific code. You can't just use any voltage, it has to be exactly 1.44 volts. That's the precise amount of electrical potential needed to get the whole thing started. But the voltage is only half the secret. This number, this is where it gets really interesting. The electricity isn't on all the time. It's delivered in pulses. And the timing, the interval between those pulses, has to be exactly 52 milliseconds. That is the magic rhythm. So when you combine that exact voltage with that very specific timing, what happens? You get a predicted 100% Faraday efficiency. Now that's a fancy way of saying that every little bit of that chemical reaction is predicted to go directly into making pure ethanol. No waste, no messy cleanup, just a perfect conversion. And this quote just sums up the sheer elegance of it all. We're not talking about some exotic, crazy expensive material. We're talking about delivering electricity to a cheap piece of copper, but in a highly specific temporal rhythm. And by doing that, you can flawlessly convert atmospheric pollution into high-energy fuel. It's incredible. So how on earth does this actually work? Well, it's not magic, it's physics. The whole thing hinges on this really powerful concept called resonance. And if you can understand this, you'll see exactly how timing can completely change the outcome of a chemical reaction. Okay, so at its core, resonance is all about matching a rhythm. See, pretty much everything has a natural frequency that it likes to vibrate at. And if you apply a force, a push, at that exact same frequency, you can pump energy into the system super efficiently and build up these massive vibrations. Just think about pushing someone on a swing. You know how it has that natural back and forth rhythm, right? If you push at the perfect moment, just as the swing starts to move forward, it goes higher and higher. But what happens if you push at the wrong time? You just create chaos and the swing stops. That's resonance in action. So that's exactly what's happening here, but we're shrinking it way down to the molecular level. Just like you time your push on the swing, this precisely timed electrical pulse is pushing the chemical reaction at the absolute perfect moment, forcing it to go down one single path. The scientific term for this is a coherence lock. Basically, it just means that the 52 millisecond pulse is so perfectly in sync with the molecule's natural vibration that it literally locks them into a specific geometric shape. It holds them in place, preventing them from wiggling around and reacting in all those other unwanted ways. So let's just walk through it one more time. The pulse synchronizes with the molecule's natural rhythm, its resonance. This locks the intermediate chemical structure into the perfect shape. By doing that, it completely bypasses all those messy, chaotic pathways that would normally create a bunch of junk. And instead, it forces the reaction down one single, clean path that produces only ethanol. Now, what's so exciting about this is that it's probably not just a one-off trick. This points to a whole new way of thinking about chemistry. Instead of just searching for new materials, we can use precise physical interventions, like timing or even gently stretching a material, to control chemical outcomes. This could be a huge shift away from the slow trial and error approach we've relied on for so long. And this table from the research just illustrates the point perfectly. Look at that first example. There's this material called molybdenum disulfide, and its surface is normally chemically dead. But if you just stretch it by a tiny amount, 1.45%, its entire surface becomes 100% active. You see? It's the same principle as the copper. A precise physical intervention leads to a perfect outcome. So if there's one thing to take away from all of this, it's this fundamental shift in thinking. It's not just about what chemicals you use, it's about when and how you apply energy to them. Precise timing, this idea of resonance, can bring perfect order to systems that are normally completely chaotic. And that could totally transform everything from making fuel to advanced manufacturing. And that really leaves us with a fascinating final thought. If finding a specific rhythm can solve this huge problem of CO2 conversion, what else can it fix? The research even hints that a similar idea, locking a material's geometry, could be used to stop batteries from degrading. What other seemingly impossible problems are out there, just waiting for us to find their perfect rhythm?